Sirius, hello. First in. Early doors. Connor, hello. Harand. The stream you've been waiting for. Quacko. Hello. I think today is the start of maybe a new mini series within the overarching stream, the story arc of UFPS. So, Julian, hello. So I have no idea how long we're going to be doing this for, but a little bit. This is 100% a side quest. Like, I probably do not need to do this at all to kind of meet my end goal, which is kind of going slightly against my philosophy of only doing what I need to do. But I think it's going to be a lot of fun. And I think it's kind of useful for my understanding and learning anyway. So there is definitely value and merit in doing it, even if it doesn't necessarily contribute to a single 1 or 0 in the final built whatever release. Betty, hello. So yeah, I think I managed to justify it to myself, and that's really all that matters. Media, hello. As long as I don't think I'm wasting my time. You're right. It's always C++'s fault. I'll write a paper, a strongly worded paper to WG21 explaining my dissatisfaction. Well, I get to be honest, like, put my streamer hat on. As long as it's not wasting your time, that's all that really matters. Right. I made some slight what C++ features to use specifically. Reflection is probably the big one. There's probably some minor ones. Have we used the heterogeneous lookup for the finished unordered map stuff? I can't remember. We used flat map for a bit. Reflection. I've used contracts personally, but not in this. There's other few bits and bobs. Yes, I think we're going to hammer on some profiling instrumentation because I think it's just kind of fun to do and a useful educational experience for us all. And it's part of this kind of self-contained from scratch ethos that we've got. But we're going to do memory first because I think that's the easiest one to do. Embed, yes, good, well remembered. So I was actually probably just going to use OpenGL. Is it query, begin query, end query when we get to the profile? I'm actually kind of. Oh, sorry, no, for runtime. Oh, no. For CPU side, no, I'm going to do something absolutely outrageous. I'm going to do. I basically don't want to litter my code with timing stuff, so I'm going to write a custom sampling profiler which runs in a separate thread. I think that's what we're going to do. Will we try and do better than the debug menu at the start? Nope, I'm going to slap it all in there and make it tomorrow's problem. Okay, so I made some minor changes to the bloom and just the scene in general. So I've toned down all the lights. So we've still got the red, pulse. I toned down the light in here. Yeah, it's gonna be a lot of fun. When we get to that, it's gonna be a lot of fun. I've done it before, so I've got reasonable confidence I can do it. So I've pushed the ambient light up, and I've dulled this red light down, and then I've tweaked the bloom a little bit. So what the bloom now has is a threshold, as you can see here, which you can configure from this. So it stops the whole scene being blurry because we blend them together. So now you can do this threshold. And then, so we've got the bloom in here, which is nice, the light. And then what I've done is I've just moved that flickering light to the end of this corridor. So as you approach here, you should start seeing it start to flicker at the end, which is quite nice. A little atmosphere. So I think the scene is just a bit more representative of like something visual that we want. It's not perfect. There's still some artifacts around like the bloom and stuff like that, which we'll just tweak as we go along. But like the machinery is there, and then you've got the red light that kind of comes out of the fog now. Yeah, I mean, I've never used any OpenGL query time stuff, so that will be a learning discovery for us, for me as well. So, like I said, this kind of mini series, I think, is going to be quite fun. There's going to be some interesting code that we end up writing. So yeah, that's kind of where I'm at now. I think the scene is a little bit better, a bit more representative of like what we have done. There's like a slight flicker I've noticed to the bloom now. Oh, I also changed. The only other thing I changed was bloom mix. Now, rather than mixing the two, it just additively Matthias, gifting subscription. Thank you very much. How kind of you. A new Twitch emotes. Oh, it's all going off. I can't keep track. But anyway, this now, rather than mixing the two, actually adds it, so the bloom builds on top of the existing light, so it should be even brighter. That's the only thing I changed. Okay, so I think I'm in a new branch. Profiling. Okay, so the first thing I want to do is I want to track allocations. Are your Twitch resub alerts not on? I've switched to a new thing, and I turned all the options on, so maybe it doesn't support that. So I don't know. Again, I'm not very good at this. So the first thing I want to do is track memory allocations. Okay, so there's a multitude of ways you can do this. Well, kind of like the granularity it wants. So we could write custom allocators and put it into all of our standard library types. So where we have like, is it data buffer? Like, because this is alias, we could have something like, you know, like a tracking allocator there. The problem is though with that is that one, it changes all the types, and two, it's not all encompassing. It will only track the things that you have changed. So if I use a std vector somewhere else, not with something other type, I'd have to remember to go and update all of them. So it's quite invasive with not actually getting very invasive results, if that makes sense. So I don't really want to do that. So what we're going to do is we're going to create our own global. We're going to override the global new and delete operator, which means what that means in C++ is that all the code that then calls new, as in the new operator, will then call your custom operator new, and then from that we can do some bookkeeping. So that's going to be the first pass. So we're going to do that and track some stuff and stick it out. So let me show you what I'm kind of talking about. I feel this is kind of like a good way of doing it. So operator new, so replaceable allocation functions, right? So it even says you can do this. So if you define any of these in your program, then the compiler and the linker will wire it all up for you, and then any call to operator new will then call your custom one. It basically throws the original one out of the way. And there's loads of these buggers, but we're not going to do them all. We're going to do the ones that we probably care about. So let's start writing some code. So that's the first thing we're going to do is I'm going to create a new directory called memory, because I think we're going to put any other memory stuff like we might need. It's going to go here, and then we're going to go e source memory, and then we're going to go new.cpp. I'm calling it new CPP because they're all defined in the new header. So this is roughly analogous to that for us. And again, there's going to be no header file because we're just going to have these functions, just these symbols just exported, right? And the compiler linker is going to consume them for us. So we don't need to hash include new wherever we go. Like, it should just work, and we'll set a breakpoint on it and try and convince ourselves that it's doing that. So first things first, so we're going to have no names. It's not going to be a namespace FPS. These are just going to be straight up functions. So we're just going to do the first one first, right? So we're going to do void. Oh, sorry, hang on. We're going to do auto operator new. Hang on. Hash include c std def std size t count, right? These are not allowed to be inlined. They're not allowed to do anything funky. They just have to exist like this, and then that's going to have to be a void star. Okay. Yeah, exactly. We are just telling the compiler, and I guess the linker by extension, hey, when something calls operator new, right? So there's kind of a difference between new operator and operator new. So when you use the new keyword, that is, I guess, I don't know if these are exactly called this, but this is the way I think of them. That's the new operator. So that will allocate some memory and then initialize the object, call the constructor. What the new operator does when you do like new int, right, is it will find the operator new, and the operator new just does the memory allocation. So whenever anywhere in our code calls new, it will then call our operator new to get the memory, and then it will do the initialization afterwards. And that's kind of a key point, okay? Yeah, things are happening. What's going on? Hype chest open. We have a hype chest, and I've opened it. Congratulations, Twitch people. You've done it. So yeah, this just all kind of works, right, in theory. So what we're going to do is we're going to do this. I guess like we could do this, and the standard says it has to throw to bad alloc if anything bad happens. And then we're going to do auto operator delete, and then I think from this you need the void star. I've got to be careful here because there's several different sorry, that'd be void. There's other deletes as well, so I'm just going to find the deletes. I can't remember if there's one that takes just a raw pointer or if it always takes a size, but we'll see the way I'm going to implement it. But the way I'm going to implement this is we will not end up caring about the size at all in the delete operators. So yeah, there's delete, throw, sorry, no except since C++11, and then there's also the array ones which we'll do, and then there's the alignment ones which we're going to do, and then there's the size ones which we're going to do because we are going to make sure we care about alignment, but that is slightly more complex for later. So there's going to be no except. Yes, there is. If you go to new, they introduced there is non-throwing ones somewhere. Is it in this header or is it somewhere else? Global 128 replaceable. The effects of the default versions are. So this just says everything that we know. There's definitely something to do with the non-throwable ones somewhere. Here you go. Replaceable non-throwing allocator functions. So you can optionally have the no throw tag, which basically means then you will support the no throwing one. So if you have exceptions disabled, it will call those. However, I'm pretty sure if you don't provide a replacement for the no throw ones, the compiler will generate you a no throw one, which just does a try, catch, and swallow. So we don't actually have to worry about that because there's nothing specific. There's no additional logic we need for the no throw ones. So we can kind of let the compiler do some of this. That's kind of my philosophy. I think there's 6 or 7 that we need to do. Okay. So I'm going to make this kind of quite Windows specific. Yeah, this is not novel, right? I think this is quite common. I mean, whether the way I end up doing it is the common way or not, I don't know. So let's do include windows.h. Oh yeah, like this is still kind of a slightly lower level of C++ that a lot of people won't have ever come across, but I think within the wider industry that like there are industries which care about this and do this quite frequently, but not everyone would be doing it. Yeah, it's GC trunk, so I think it's technically building for 17, but it's basically 16.01 or whatever the latest one is. Okay, so we're going to do auto heap handle. Okay. So we're going to use a custom window. We're going to allocate a custom heap for this. You don't have to do this, but I want to use all the Win32 functions for this because 1, they are inherently thread safe. 2, it cuts out all the U, CRT, and CLib gubbins and just goes straight to the kernel. And 2, there might be some interesting stuff we can do later if we have everything kind of siloed off into a separate heap. So I'm kind of hedging my bets a little bit, but also I think it's kind of fun to do. Handle is just the Win32 type that a lot of their functions return. It's just a handle type. It's just an integer, or is it a pointer? Technically, whatever it is, you can think of it as an integral number. It's like a Linux file descriptor. So if we look at right, so what we're going to want to do, void star. Okay, fine. I mean, you can. What it is actually irrelevant, right? Basically, like it's just an opaque handle to a thing. Okay, so let's do. I'm going to try and remember that. So static auto h equals const auto h equals get. No, sorry. Create. Is it not in the? What header is this in? It should be in Windows.h. Why is it not liking? It might be because ClangD hasn't caught yet because I've not actually compiled the file. If h equals invalid handle value, then we're gonna throw stood bad alloc return h. I think that's what I want. Hang on, I'll get there in a minute. And then immediately invoke that and then return h. Is it heap create? Thank you. Yes, you're right, it is. Nice. Okay, we'll go through the flags in a second. Okay, so I just want to statically initialize one heap on the first call, so lazily create it, and then forever use that. Because there's a massive issue with like the static initialization order fiasco, and I'm trying to just avoid that. Stood accept. But it's heap Windows only now. Yes, this is a Windows specific code. Okay, so this just uses immediately invoked Lambda to statically create a heap and return it. So the idea being that any thread that comes through here is guaranteed to thread safe in a thread safe way. The first one will call this, and the rest will just use the initialized value and then return h, and then that just returns the same handle every time. It just means that in a reasonably performant way, the first call will construct it, then everything else will use the same one afterwards. Heap create, I even had it up, so I don't know why I did create heap. Creates a private heap. So in Windows, you can have as many, you can create your own heaps. They map in pages, do all that kind of stuff for you. Creates a private heap object that can be used by the calling process. So options, I don't want any of these, but we might want them maybe in future. Well, I definitely don't want it to be executable. We can have it so that it generates exceptions when you try and access stuff outside of that allocated heap rather than returning null pointer. And we can disable serialization, which makes it thread unsafe, which we will not be doing unless we had a per thread heap, at which point we could then potentially turn it off, which would give you a little bit more performance. Initializer size is going to be 0. I don't care. Like, we're just going to grow it, and then maximum size is going to be 0, so the heap can grow. So you can give it an upper limit. You say, I want my heap to never be larger than this, and that's fine. But other than that, we're going to keep growing. But we give it 0, so it means we can grow. So this means we're then going to do. What about stood call once? I prefer this. I don't know if there's a functional difference between that and stood call once, because you still have to have like the global call once flag, right? I find this maybe more palatable because you can still have to pass a lambda into call once anyway, right? My preference is create heap because I want to use the Win32 API anyway, and I don't really want to worry about synchronization and locks and stuff like that. So heap alloc and heap free will kind of handle all that for me and do a lot of the metadata tracking for sizes and stuff. If we wanted to, so I think it's a great question. The beauty of this approach, right, is that because it's all contained in a single translation unit, we can swap those out, right? So if we do all this for profiling and we think, oh my goodness, like this is an absolute nightmare, we need to go even lower level, we could have a virtual alloc new CPP and we could use CMake on an option just to compile, put that in and out. I think this will get me, This gets me all of the requirements I want with probably the smallest amount of code, okay? And that's not necessarily what we want in the end, but it's what I want now. And we can do other stuff, like I think you can set options on the heap to maybe always initialize it to 0 or not. It's not at the moment, so we could add like a poison value to it and stuff like that. So it gives us a little bit of flexibility. But the main thing is that it gives you known alignment qualities, and it gives you, it's kind of thread safe guarantee, but it goes straight to, it's just a kernel 32 call, right? That's my kind of thought process. I'm prepared to be wrong, as I am with most things. Okay, so auto pointer equals, so now we can do heap alloc with heap 0 and then count, right? Yeah, I know, right? That's how I find out I'm wrong, is I put it as a short, wait for people to tell me I'm wrong. Let me see, heap alloc, I think I want this middle flag to be 0, but let's just checky check. Accept, go away, flags. Generate exceptions, heap alloc. So you can override those. This can be 0 initialized, otherwise the memory is not initialized. So if we wanted to have like a safer one, we could initialize it to 0. No, there's no tracing in this. So if pointer equals null pointer throw stood. I think I want bad alloc there, right? Turn pointer. I'll accept cookies from anyone. And then to delete, we just do heap free. The pointer we get heap, the point 0 flags and pointer again. Let me just check what those flags are. So those flags are no serialized again. So you can per allocation say whether you want it to be thread safe or not. There is, but it won't throw it will raise a Windows exception. It won't throw stood bad alloc, which I believe the standard mandates that in this specific situation, your exception should be a stood bad alloc. I've got a feeling, I could be wrong, I've got a feeling certain machinery in the standard library will catch this, but I could be wrong, but I'm prepared to be wrong about most of this, but I'm pretty sure the standard says this should be so we could raise a Windows exception, register a vector exception handler, and then handle it like that, but like this seems easier. Yeah, it's because it's still a C API, right? It's just the fact that you can have this is why Windows is great, right? You can have exceptions in C. What's not to like? So let's do copy source. I don't know, something like utils cmake into source memory there, and then cmake that, and then this is just going to have new. Yes, correct. Only, but which we've not configured. We'll just get the null pointer back, and then we will raise that as a C++ exception. And then cmake. So this is going to add scmnomm memory. Okay, fine. So that should be kind of enough to get going, I guess. Let me just check this is actually hit. The program should define. Oh, it's fine. Oh, interesting. The program should also define the size type. Interesting. It will not let you do one but not the other. That is fine. We can handle that. The nice thing about heap free is that this is the other reason why I wanted to use heap free, is because Microsoft Windows automatically does the bookkeeping for you, so you do not have to pass. All you have to give heap free is the pointer that you got out of heap alloc. You do not have to pass the size back. It can calculate that for you. So this is, in fact, actually, this is just then operator delete pointer, right? So we can just call the other one, right? You have to, if I have to scoping this, make sure it definitely calls this. So that's, I think, all we want. So if we set a, let's just check this builds. We're going to build out, we're probably going to spend like at least an hour building out this machinery, and then we'll add the instrumentation, because we have to do all of these, I think. So let's just see if this runs. It should get hit pretty quickly. Yeah, all right, it's hit straight away, right? And you can see here, it's calling it in the standard library initialization code, some static initialization in the CRT setup, and then my log code, interesting. Okay, and then the basic code stream stuff, which I guess has to be initialized before everything else because the static stuff. So damp. So that gets called. Is there merit to putting all these in namespace and having the globals just call them? Possibly. I really don't think there's going to be that much duplicate code, because what I'm going to basically do is just call, I'm going to chain them all anyway. So I'm going to, where possible, just call one in terms of the other. So I don't think we'd get much. I don't think it would get as much, but it's a good point. I think we should possibly write some tests for this. Like, well, actually, I'm in two minds about whether we should write tests for this, because if it doesn't work, like, then none of the tests will pass. Do you know what I mean? Like, if new is buggered, I don't really know what we would test other than, like, we get a pointer back and then we can hand it off. So maybe we might need a test for the aligned case. Yeah, exactly. So okay, so then the next one is gonna be, so that's easy, right? Bish, bash, bosh, done. That's, you know, I think we could even treat ourselves to a commit then. So let's do initial new delete overload. Yes, we will, and also SIMD needs forced alignment as well. So something internally might have to allocate something on 32 or 64 byte alignment, bit alignment. But again, I'm pretty sure. Oh yeah, we do actually have alignment. I think so. Heap create is in here, or heap alloc. Here you go. The alignment of memory returned by heap alloc is memory allocation alignment. So on 64-bit systems, you are always guaranteed 16-bit alignment. Okay, so it's just if we want anything above that, we will have to handle that. Have I ever used fixed point types? As in, can you fixed? As in for floats? As in for real numbers? Or there's the fixed width types. Fixed versus float. I only ever use floats. Yeah, I just use floats. Okay, right. So what's the next one? So we also kind of annoyingly have to do auto operator arrays, right? Which I wouldn't probably use that much. But I'm pretty sure I can just do that, right? Because heap alloc don't care if it's an array or not. I don't. There's not a sized one for that, is there? So I think for delete, I just have to have that. And probably that. Probably should actually check this runs. It might actually crash because we haven't done the aligned ones yet. Oh, okay, fine. So far, no alignment issues. Unless if you don't provide the alignment. I wonder if... I'm not quite sure. I must admit, I'm not quite sure of the rules of how these kind of interplay with each other. So if I provide this, but I don't provide the aligned one, does the compiler still use the default aligned one? Or because like with here, it's like, you definitely need the size one, right? Guess we'll find out. Okay, so that's the array one. So the only other one I think we need to care about, and this is the fun one, is align value t. So this says I want this many bytes, but it has to be aligned to this value. Breakpoint on the alignment code and see where it goes. I think it's in a vector though, isn't it? I don't think I knew. I guess if we had tests, I need some tests. Might need some tests. Memory. Oh no, I don't even need that, do I? So this should be just like test. Memory. I can't just use new because that's a keyword, isn't it? New size. Is that true? False. Memory. Did I change the array size delete to call the array delete? I don't think I need to, because at the end of the day, it's all gonna go down the same delete hole. What? Cannot find source memory tests. Oh, they new tests. What was I just writing my tests in? New tests. All right, let's try that. Okay, nice. Okay, so I suppose we could do like auto x equals. Oh, we might. Hang on. We might be able to construct a test here. Just thinking. Here we go. Hang on. Right. Okay. It's gonna be a little bit gross, but I think what we can do is we can do auto x equals operator new 100, right? And then we can do assert greater or equal heap size of x 100, right? And then I guess we probably should do operator delete x. Oh, this has got like 0. What will be DW flags? No serialize. A pointer to the memory block is. Oh, you need to get the handle. That's annoying. Do we expose that? Hang on. So I'm going to do name space UFPS. It's a little bit gross, but it's fine. And then we're going to do inline. Turn that off. Inline auto allocation size void start pointer stud. What's this return? Stud size t return heap size heap 0 pointer. So that's, I don't mind writing a bit of code for testing because I do think it makes things a little bit easier, but I'm not expecting really to use that much. So this is going to be assert greater or equal to assert UFPS. So I now will need to include that. Oh, it's in the bloody CPP file, isn't it? But actually, this is a good way of making sure no one actually uses it, as I can just auto allocation size void start pointer stud size t. If I forward declare that, then I should be able to do. Can I forward declare something in a namespace? Yes, I can. Yeah, well, we all make mistakes, don't we? Right, okay, so that should... I have to check greater or equal because Windows might allocate additional space for bookkeeping or whatever alignment or whatever it does internally. Bleh. Undefined reference to UFS allocation size. Are you sure? Have I typoed that, or am I just being stupid? You can't forward declare it if it does type deduction for the auto, right? But I can if I explicitly specify it. Why is it not finding that? Oh, it doesn't need to be. Inline doesn't make any sense in the CPP file, does it? Sorry, I was thinking this was in a header file because it will give it internal linkage and it won't be able to find it. Idiot. Right, so that's better. I don't know why. My setup is a bit strange at the moment. It really wants everything to be declared like that. Right, nailed it. Sorry, brief C++ interlude. So let's do new array. We'll do new array and delete array. So that should do the same thing. Nice. Okay. This is no except, right? So there's not really a lot I can test on it, but I'll just do it anyway. Yeah, well, it was an argument with the linker, and then it was an argument with the compiler. Okay, right. So now I think this feels like. What the fuck am I downloading there? Right. Add more new delete operators. Okay, fine. So the next one is the fun one. So this is align T. So let's find out what I'm doing. So I want auto operator new stud size T count stud align val T alignment void star. Right. So what alignment means is like it's effectively the multiple the multiple that the address is on, right? So if you want it at 32-bit aligned, the address has to be a multiple of 32. Something computers are hard. They're just like lots of transistors, right? And when you fetch something, the chip layout is optimized normally to fetch data or instructions with a certain alignment. x86 is normally quite forgiving and will execute unaligned instructions and access unaligned memory for a performance cost. ARM is very unforgiving and will segfault, or whatever the equivalent is, when you access unaligned data. For the most part, we don't care, I don't think, but we should do this if we're doing this, right? Because we want to capture all allocations, which is the main thing. So we can't just go new and return it, because we want to capture all allocations, which means we have to overload this method, which means we have to abide by the alignment request that's been given to us. Yeah. Oh, ARM is forgiving nowadays. Okay, fine. Last time I looked at ARM, it was very unforgiving. Maybe my knowledge is old. Sorry, if I get bit and bite the wrong way around, it's just because it's just inherently like just doing stuff live. Do you know what I mean? Like I do my best to kind of be factually correct, but I misspeak sometimes, and I'm still trying to talk and explain all this and write the code at the same time, and I will make mistakes. Line 54. Yes, good spot. These were added in C++ 17, I think, or 14, the specific size ones. It just allows for certain optimizations in certain cases. Again, because of our heap the manual heap we're using, we don't care, but some people do. Okay, so the best way to do this is you effectively have to over allocate, right? Because I cannot, well, actually, let's do this bit by bit. So if al is less than or equal to whatever that rando macro is, which I already don't like, but what are you going to do? Sometimes macros are inevitable. Memory allocation alignment, right? Then just return operator new count, right? Oh, is this some weird magic type? Const auto alignment equals static casted size t al. Okay, so we are guaranteed by the Microsoft documentation, and that's never wrong, that heap alloc will give you 16-byte alignment, right? So if the alignment value we've been requested is less or equal to that, then we can just use the regular one, and that's done. So it's this case we have to do. So basically, we have to over allocate, right? Because what we have to do is we have to allocate more space than they've asked for, so that we can return them a pointer offset within that, such that the pointer meets the alignment criteria they've asked for, but there's still count bytes on the end of it, right? If that makes sense. We have no idea. I mean, we could get lucky, and the address it returns us is aligned, but we can't rely on that. So we have to assume that whatever we've been returned is unaligned, and then offset it such that you do get that alignment. So I'm going to try and get this right, which is almost certainly going to go wrong. But also there's a key issue with this. Okay, I will return back a void pointer, right? Okay. Step 1, give back a void pointer. The guarantees that I make on that void pointer are that there's this many bytes on there hanging off the end of it, at least, and it's aligned to this, right? What that means is the pointer I return is almost certainly not the pointer I got back from heap alloc. It'll be some offset into that allocated memory, but delete, that really, really needs that original pointer. So we will have to stash the pointer in some of the unused space so we can recover it. The implications of being wrong are it's undefined behavior, so anything could happen, right? I've not met my promise of memory allocation. Heap alloc, well, virtual alloc just allocates pages, right? So you can only get a 4096 multiple, right? And that just maps more pages in to the virtual address space. Heap alloc will have some logic behind it, which allows it to be thread safe, which it might have some optimizations like a free list or something behind it. I don't actually know what the internals of heap alloc are. All I know is that it's probably what malloc calls under the hood eventually anyway. So they are kind of different. One's a page allocator and one is a memory allocator. Effectively, yeah. So I'm going to try and get this right. So we want const auto new size to be count, right? Plus alignment plus size of void star. Right? So that's going to be the amount of size that we want. So if we always add the amount of alignment bytes that they've asked for on the end, we're guaranteed to be able to shift that pointer somewhere within that. And there has to be somewhere a pointer within in that amount which aligns to the pointer, or which has that alignment, right? So if we add the full alignment to it, then we have that much buffer to offset what we send out to them to make sure we fulfill that alignment criteria. And then we're also going to need to stash the original pointer somewhere. There is a delete aligned, I believe. Yes, there's a delete aligned, which the machinery will call for you. So it knows precisely because of this, right? Because they know you're going to have to do some extra bookkeeping to meet the alignment requirements, the delete operator automatically handles that. You go to the top 16 bits of the pointer to store the alignment. I don't think I need to. Like, I'm going to try and keep this as simple as possible. So now we can do const. No, it's not going to be const. It's going to be auto pointer equals operator new size, right? So this will indeed give us that, and we know that we're going to get bad alloc if it all goes wrong. So then you could go and do all the alignment maths yourself, or you can be lazy and do what I'm going to do, which is use stood align. Stood align is an interesting function. You give it the alignment, right, and the amount of space in a buffer. You then give it a reference to a pointer, right, and a reference to some size, and it will update that pointer to be an aligned amount within that and tell you how much space you have remaining. What's wrong with stood align? Like, it literally does all the work for you, right? Unless there's some nuance I'm missing. Oh, I see what you mean. Yes. Okay, fine. Yeah, I understand your point. Harand is very precious over his tax space and likes to see none of it wasted. So what we can do is do auto size t. Auto size equals new size, and then what does this return? So then we can do const auto aligned pointer equals stood align. So we're going to put in alignment new size, pointer, and size, right? And if that equals null pointer, then it was not enough space, and then we can just throw stood bad alloc. Okay, right. So now, in theory, we should just be able to return pointer, but we're not quite done yet because we still have to stuff this in. So now I've got to kind of remember how this works, because I want to... I'm trying to work out if I'm guaranteed to have void pointer space before the alignment. I think I am. So I think what I can do is do reinterpret cast void star star aligned pointer, right? And then subtract 1 from that to wind it back 1 value, and then stick into that the original pointer that we got out. We're taking a bit of a side quest to do some memory profiling. I think it's gonna be fun. I think this is horrifying, but I think this is correct. So we're basically going to say, given the aligned pointer, let's wind that back 1 pointer size worth, and then shove in the original pointer. Okay. Wind back 1 value, or well, because you have to remember that this is that right? Hang on a minute, because I've got a double pointer. Yes, this will wind back the size of the thing you're pointing to, which is a void pointer, right? Because if you did int x, if you had a pointer to an int, right, and you did +1, it would add 4 bytes to it. Yeah, exactly. Yeah, that's why I'm doing it. Okay, so then we should be able to do, what have I done? I'll try and keep these roughly in order, although I already hate everything. Auto operator delete void star pointer. Do you get the size in this as well? Or do you only ever get the align? Oh, you get both. Okay, fine. Let's do stud align value t al no except, and the rest can just call this. Okay, so we've got, so assuming I've done it right, this pointer, in fact, actually, we're not even going to need to know the alignment now, right? All right, this should, in theory, now be the aligned pointer that we gave out to someone. And then, so now I think I can just do, sorry. So used to writing concept, right? Auto star rig pointer equals reinterpret cast void star pointer -1, right? That will give us the original pointer back, and then we can just do operator delete array pointer again. We don't talk about size because heap alloc and heap free take care of all that for us. And then if we just do which way is it? It's size t there, and we can just do right? So if we do pass in alignment, where do I want to pass in the alignment? So if we now do oh, have I passed in the wrong one? No, I've recovered the original pointer, right? And this, oh, I see what you mean. Yes, sorry. Yes, what a great spot. Yes. Yeah, good spot. Okay. What I think we can do is struct align as 32 foo int x Can I just do then auto f equals new foo? Do we think that's... Because that will then call the allocator, right? But this should force the alignment. I guess I probably should just call it manually, shouldn't I? Rather than just faffing around with that. So let's say I want new. I want 4 bytes, but I want it to be stood align T4, I guess. And then this will have to be operator delete stood align T4. And then this should be at least 4 bytes. Although, oh, that's not going to work though, is it? I won't be able to do allocation size on it because that won't point to the original pointer. Might not be able to test this one, which is a bit annoying because, like, what am I going to assert? I guess I could just test it works. That is a good point. I could do the manual misery, couldn't I? Okay, so let's do let's do auto star rig pointer equals star. This is a reinterpret. Pretty sure this is a UB. Might not be x -1. And then we do a rig pointer. That should be at least 4 plus 4 plus size of void star, right? Because that's what we requested. Test this macro, yeah. Yeah, I think it is guilty knowledge, but I've got to see if it works. I think that crashed. I mean, I'd rather test public interfaces, right? But for this, which is pretty low level, like, it's all guilty knowledge, right? What have I done wrong? Void star means I have a pointer to a void star. I think I'm gonna have to, because I don't have any of my fancy new inbuilt debugging stuff set up for tests. So I think I'm gonna have to run this. That's fine. Don't care about that. Okay, I don't want to pause on exceptions because the tests throw exceptions. Here we go. Right. Oh, interesting. It's on heap. It's on allocation size. Well, you should memcopy it, right? Because the compiler will often elide that anyway, and then you get the guaranteed lifetime, starting of the lifetime with memcopy, right? So it is all quite nuanced. Because I think this is fine because I'm still getting back a void pointer, right? Like, I've not changed the type, and I don't have any. I'm not violating the strict aliasing rule. I don't think. I guess technically this is now a different. This is potentially, yeah, I guess. Although I don't dereference this, so I'm not reading from a point, because this is constructing a pointer to a different type with the same address, which violates the strict aliasing rule, but I'm not actually dereferencing it, I'm merely offsetting it, so I think this might be fine. Yeah, the logic is almost certainly wrong. So what do we do? Where do we go from here? So I think we need to probably step into this. I will try and get it set up so I can run the unit tests under my debugger, but for now this is fine. least it's working. Okay, right. So we asked for 4 bytes and an alignment of. Oh, I don't want an alignment of 4. I want something bigger, like 32, don't I? Because this should just go through here. So this is a good. Oh, I know exactly what's going on. Because we've gone through this, we've not stuffed the pointer in there, have we? So, in fact, I know exactly what's going on. This is a new aligned Win32 default alignment. Okay, I've seen it. Okay, so this should have in here a similar thing, right? If alignment is greater or equal to memory allocation alignment, then we just pass this through to operator delete pointer, right? Fine. Sorry, we will get to actually doing some metrics soon, but I think it's worth building this out because this is kind of prerequisite for all this anyway, right? And it's kind of, I think some. Okay, we still crash, which is upsetting. Oh, hang on. Because our guilty knowledge test now doesn't work, doesn't it? We just want to do x is at least 4, right? There we go. Right, and now we want to do into default align Win32 larger alignment. So we're going to go something like 32 here, and then we need to. Why did I delete all that code? That's stupid. Right. Arrow pointer, and this should be 4 plus 32 plus size of void star. Right. Happy with that? It needs to be 32. It was worth writing those tests because finding that when it's like embedded in some sort of miserable container. Wop, wop, wop. Okay. Let's debug it. Oh. Oh. We've got a non-deterministic crash. Sure works in VS Code. Boring. So that should wind that back. That should be. That's a massive pain if I can't see where it's crashing. So let's step in. So that's fine. So it's going to get new size, which is now going to be 44. It's going to get the new size, and it's going to set that, and then it's going to align. So hang on, pointer is currently BE08. So if we step over that, align pointer. Oh, interesting. The issue there is what do you do if it's already aligned? It's giving me back a 32-bit aligned thing, and then I basically wound it back into no memory. So I think what I need to do is give it a pointer plus void plus size of void star in, right? So I've always got that space, then that'll either be aligned or it will offset it, but I can always wind it back 8. If that makes sense. I think that's the issue. So let's go new. So I guess there's a couple of ways. No, it has to always be wound back one, doesn't it? I always have to make sure there's that extra space at the beginning. So pointer here has to be. Oh, you're right. I've also returned the wrong pointer. That's kind of funny. There's another bug anyway, because if this is already aligned, then I don't have the space. So pointer needs to be. Ugh, I really hate doing pointer arithmetic with void start. It's such a massive pain. Auto offset pointer. Equals reinterpret cast void star reinterpret cast char star pointer plus size of void star. Okay, and then that is offset pointer. So that will always give me 8 bytes in. It will then align that, which I'm guaranteed to still have enough space, I think, because we added at least the alignment and the size of pointer. Yeah, it's pretty gross. Bad airlock thrown in test body. Well, it's better than crashing. It doesn't like this. I bet it's that, and I bet it's because it doesn't. Why we didn't have enough space? Which size needs up? Oh, yes. You're right. I guess this now technically has. So that's minus size of void star. Well, that would give it less space, right? And that is minus size of void star. Oh, it's getting a bit hairy, this. 953 needs updating. Why would this need updating? Because I've already added the size of the void pointer onto it, right? That's what I'm saying, is I don't understand why this isn't working, because new size is always guaranteed to have at least alignment bytes on the end of it, plus the size of the void pointer. So if I shift in this mount, right? So if I add this to the return pointer, there's got to be at least this much space on the end of it, right? My only thought is that maybe these are now wrong, because I'm technically aligning it. I'm technically aligning something and more to the offset pointer. That's not in that space. Yes, so you're saying this needs to be like ×2? I'm just going to just double check that is indeed that. I can't see where else this would be failing, but I do want to just double check it is that, and I'm not fixing the wrong issue. Yeah, that is 0. So why is that? No, I'm trying to figure it out, right? So we guarantee that there's at least 8 bytes at the beginning. I think all these sizes are, I think this is right because yeah, let's have a quick look. That's a good point. Okay, so alignment is 32. New size is 52 because that's 4 plus 30. Why is new size 52? So that should be 8, 40. Why is it not 44? Why I'm not mathsing correctly? That'd be 8. 8 plus 32 is 40. 40 plus 4 is... Oh, these hex values. No, they're not. What? Am I being stupid? Am I missing something really, really obviously trivial to everyone else? Yeah, but there's no fun in getting the AI to solve the problem, right? Like that, solving problems is fun to me, right? So this is, I might not be on my face, but this is fun, right? I don't want the AI to take all my fun. Void stars 16, I guess, but like why? It could be a stale build. Yeah, hang on, let me just yeah, okay, fine. I think we had the pointer 2 in there, so God, I thought I was going absolutely mad for a second then. Yeah, right. Okay. Alright, okay, I'm not going mad. Okay, right, so let's go through this. So then we're going to go size is that, offset is that, right. So we're going to do, so we get back 0. So the alignment is 32, the new size is 44. So new size is 44. That's the size of the buffer, which I think is technically incorrect now, right? I feel like new size needs to be reduced by size of void pointer. Because there's not that much data left on the end of it now. So that's minus size of void star. Still failing. Why? Because I'm effectively telling it to align a smaller buffer, right? And I guess this as well also needs to be minus size of... But I just feel like I'm just kicking the can down the road, right? So we take the pointer, which is returned by the operator new, we offset it by the size of the void pointer, we then turn that back into another miserable void pointer, and then we say align this please. Please align based on the given alignment. The new size of the remaining buffer is new size minus void star. write it out to the... This is the pointer within it. And this is the size. I feel like I'm missing something quite fundamental here. Should the new size minus 4 and the align call just be new size? Oh, yes. Am I double subtracting it now? No. I don't think so, because this is... I suppose actually this should probably be size, right, to be consistent. Yeah, let me... Right, size, right? The size of the storage to be aligned, okay? The desired alignment, a pointer to a contiguous storage buffer at least space bytes, the size of the buffer in which to operate. I don't... Those are all true, right? This is at least this size, right? Because I've allocated new size. The only thing I can think of is if there's any extra padding. No, because it would always be at least that big. So the last size should be the whole size. I don't think so, because it's the size of the buffer in which you're operating, but what you have to remember is I'm effectively giving it a smaller subset buffer, right? I've over-allocated, and then I've sliced off the first 8 bytes, and I've said, now please align within this remaining one. So that remaining bit is my, for all intents and purposes, is my buffer, right? And it's only so I can guarantee that I get 8 bytes behind it. The other thing, right, I guess what we could do is do that and then do something like that. Because you definitely get enough space for 8 bytes before then. There you go. Not sure how I feel about that. I'd rather, it feels a shame to over allocate by so much, but in the grand scheme of things, I'm sure it's not going to make much of a difference. If the size and space in the line are the same, then it cannot. Yeah, I wonder if that's the issue. Anyway, like if we give it like 2 lots of alignment, then I'm definitely going to get 8 bytes before it. So I think that might be all right. The main thing is that you wind back the pointer you're returning, you wind it back 1 and you give it the original pointer, and then you can recover it. The extra stuff is kind of irrelevant. I think I'm okay with that, and I kind of like to make progress elsewhere. Oh no, non-deterministic tests. Oh. Right, I think again it's the same issue. I bet it must be working when it's failing when it's either already aligned or already not aligned. I don't know on which happy path that is. I can't bother to do the bit maths. So I feel like we're just back to square one now, because I can be like, well, just minus alignment, right? I know, but I feel like I've started now, and I really want to finish it. I really feel that I'm so close to getting this done, right? So close to getting this done. Pointer to buffer of size space. This is definitely going to be like minus alignment. Essence size doesn't need to be new size minus. Yeah. No, I just... Right, I'm going to do this for like 10 more minutes, because then I do actually want to do some of the tracking stuff today, and otherwise, yeah, I just fix this off stream. Why does an align function care about the size? Yeah, I don't know. Yeah, so all that bit twiddling math stood align should do for you. It's just annoying me because we're so close. No, never. No main bit twiddling when stood align exists. Pass count as second parameter to align to size. Well, this should be the size of the storage to be aligned. Which I bet you're right. I wonder if that's it. Because that's the amount of space we need. That's the amount of space we actually need to align on, isn't it? I was trying to align for more space. Yes. Oh, what a great spot. So in fact, I think I can now actually go back to having this as plus size of void star. Keep it civil in the chat. I really do not have the energy to go and like sort it out. So just be nice. That's not that much to ask. Okay. I like that. Right. Okay. Add, aligned, new, delete. I guess technically I need to do the array one, but like we can do that later, I think. Okay. That is... Oh, bad. It's going to super quick do the... I'm going to do the array one before I forget, because I will forget and I'll be like, why does none of this work? But this should just be as simple as return operator operator new count. Ow. All right. And then delete. I'm gonna need these ones here. So it's gonna be that in there, and then this is gonna be new tests, and then why is this in this window? What have I done here? New tests. And then I guess we should just new. Might be the longest test name yet, which is exciting. Okay. Right. It ran 3 times in a row, which means it has to work. Yeah. Okay, right. Got half an hour, maybe an hour, maybe a little bit more. Let's see how we get. Right, let's do some metrics. So now that we've got all this gubbins, we can start tracking interesting things. Sorry, now that we've got all this, because we basically only have one function, right? All this really does is eventually boils down to an operator new. All the other stuff is a bit of bookkeeping, but really we just have this. So this is thread safe. So if we just have a bunch of atomic for counters, we can track how many, like the number of allocations we've done. We can track the total allocations we've done, and we can also track the live allocations by just decrementing the free count, right? Unfortunately, ASAN and USAN doesn't work on my setup because MinGW doesn't support it. So for ASAN, we just have to hope, which is also why I make everything const expert where I can. But yeah, I really wish I could have ASAN. It's really it's one of the failings of this project setup. Okay, right. Let's do I don't know where to put it. Core utils let's put it in memory because otherwise it's going to get a little bit lonely in there. Let's do memory metrics.h. Once namespace UFPS. Then we're going to do hash include atomic hash include cstdef. So I'm going to keep this super simple because metrics should only really be used in debug builds. So I'm not going to build out a whole class with an abstraction, which I would normally do. I'm going to keep this just as a struct, as a global struct, basic, and yeah, like anyone can kind of use it. It'll be global, which I wouldn't normally do, but for something like this, like I think we can kind of keep it simple. So let's do struct metrics. Let's do stirred atomic stirred size t. So let's do total allocation count. Do total allocation bytes, and let's do live allocation bytes. Total allocated bytes, and then live allocation bytes. So I get to mix and match programming styles today. Does it make sense to do? Because what I was going to do is every time we have a new, just increment this. But I guess that's kind of useless to know the total we've allocated across the whole program. So I guess I probably just want those two to start with. Yeah, I will mGUI plot this. And then I guess like inline. Hang on, I could get this right. Inline auto g metrics equals metrics, so that everyone should have access to the same one now. Okay, so we want total allocated bytes. I also want to do because our game has got quite a nice synchronization point, right? You start a frame and then you do all the threading and everything stuff, and then you swap. When you swap the windows, at that point all the threads are stable, right? They're all doing nothing because you've drained all the job queues. So we can also then have like a frame counter, so we can see what we're allocating per frame and then plot that over time as well, which I think could be interesting. Inline and static don't make sense together, right? Because static means it's you have it per translation unit, whereas inline variable means I'm going to have this declared multiple times, but please make sure that hey, Mr. Linker, please make sure everyone sees the same one, I think, right? Because I don't want each translation unit that includes this to have its own metrics. I want there to be a single global one. I could also use just a singleton pattern to like we did for the getting the heap, but I think this is all I want, right? Because I can just initialize this. I think as well, in fact, can I even have const in it as well? Which means that this gets created at compiler time. So there's no doesn't that elide the static initialization order fiasco as well? assuming atomic is const expra initializable. I guess we'll find out. Because what I'm going to do is I'm going to slap this in new, and this is instantly going to be in every single translation unit. Memory, and I guess this would only be in one translation unit because it all gets linked in, actually, isn't it? Let's just see if this blends. Yes, you're probably right. Sorry. But it's whether they are marked as const expra, I guess, which I guess they are. Okay, right. So now what we're going to do is when we do new, assuming we've got this just before this. So what we could have, remember, we could have a debug. We could have a. I'm going to do this all in this one translation unit, right? In UCP, but we could, in theory, have a tracking new and a non-tracking new, which doesn't have this, and then we could use CMake to control which one we include. But like for now, let's just shove it all in there. So UFPS G metrics dot total allocation count dot is it fetch add? I think it's fetch add, isn't it? Well, because what I want to do is I want to relax the memory model because we don't need synchronization. Fetch so fetch add 1 stood memory order relaxed. Yeah, because atomics give you two out of the box. Default atomics kind of give you two things. They give you atomicity, right? So you don't get torn, read, or write. So you're guaranteed that each action happens atomically and indivisibly, but you also get effectively a form of synchronization where you are guaranteed that reads and writes are seen by other threads in the order that they happen if you go for full sequential consistency. But for this, like, I don't care about any of that. Like, just write it. I think on x86, I don't think it makes much difference, but it does make a big difference on ARM. Yeah, I think everything's going to be relaxed. Matthias, see you later. Thank you for joining us. Right, so then total allocated bytes then becomes fetch add count. Well, actually, I'll tell you what we probably should do is we probably should do heap size heap 0 pointer, right? Because Windows might over allocate for bookkeeping on its size, whereas I think this gives you the true value. So this will guarantee that we'll get the number of bytes that were actually allocated. And then what was the other one? Live allocation bytes is also going to be the same. Let's do const auto real allocation size equals heap size heap 0 pointer fetch add cf real allocation size I don't know. Like, I'm kind of figuring a lot of this out as I go along as well. But I think I'd rather keep it consistent, right? Right. And then we're going to have to do this on the delete side anyway, because this is the only time we actually need the size. Whereas So here we can just get recover that size, and then add just becomes sub, sub, sub. And we don't do the total allocated bytes, right? Yeah, I mean, like I just want to get something going, right? So in theory now, that we should be able to see this. I think what I might do in metrics is have a inline and just have like inline auto metrics metric snapshot. This might be the only kind of thing that I write that's kind of like functiony dot return, just so I can then do dot total allocation count equals g metrics dot total allocation count dot load stood memory order relaxed, right? Just so I can get those in there. So this will just give us effectively a read-only copy of it. And that's one thing at a time. One thing at a time. You're right. They should be in order. Sorry. That should be total. Total. That's right. Something like that. So what was the concern? Should total count be live count? You can't have. Can you have? I don't think you have an atomic on an arbitrary struct, right? I think that it's only atomics are only supported for the built-in types, aren't they? I thought you could only have these types. I could be wrong. I've never used an atomic on a rando type before. I think it's only supported on the basic types because it knows how to issue instructions for them, and I don't think it will decompose. There's no way of doing it because atomics map directly to x86 instruction or to instructions, right? So in this case, x86. So x86 has atomic instructions for all the different size types, but anything bigger than that, it would have to compose them, and then you wouldn't guarantee atomicity. So you would then have to introduce a barrier, at which point you might as well just use a mutex. Yeah, I just don't think it. I don't know how you would guarantee atomicity without introducing a barrier. At which point you kind of gone away from the idea of the atomics, which are super efficient ways of guaranteeing avoiding torn reads and writes. Right. Anyway, I'm guessing now, not doing any work. So let's go to my least favorite file in the world, and then let's go down to where do we add a new window? Yeah, exactly. I think you would need to introduce that yourself. Hash include memory metrics. And then it's something like render targets. Let's create a new window here. Sure, good a place as any. Right, and then let's do const auto metrics equals M equals metrics. Oh, they have a structure today. I'm just surprised that works. I could be wrong. Like I said, I'm absolutely not an expert in this. I know that you can query if it's lock free, and I think the only one that has to be lock free is atomic flag. Oh, here you go. Here you go. Interesting. The primary stood atomic template may be instantiated with any trivially copyable type. There you go. Well, there we know. I'm going to leave it as it is because I think that's going to work. I don't think we're going to be calling it only once a frame really anyway, but it's interesting. I didn't know that. So we want imgui like num. Hang on, I've got an example of this. It's like the first thing I do. I have the frame count, isn't it? Oh my god, I hate this. I hate this file so much. FPS label text. Label text, and this is going to be total allocation count. Format will be ZU, I guess, and then it's going to be m dot total allocation count. Yeah, I know. We should probably reflect this out, but let's just get something working first. So then we've got live allocation, no, total allocation bytes. Allocated bytes. And then live allocated bytes. We can graph this as well. Let's just see if this works. Okay, let's dock this with this one. It crashed. Why did that just dock it? Is that a bug with imgui's docking, or did something horrific happen? Or is it to do a miserable memory allocator? Let's just let it run for a bit. I feel like this is... I feel like this is not doing a lot. Like, why is total allocation count just stuck there? Am I really not allocating anything? Oh, it really doesn't like docking that. It really doesn't like docking that. Is that... I wonder if that's... I bet that first window isn't a proper window. I bet it's not. Oh, it does say scene, so can I dock that with this? Okay, so it'll go there. And it'll go there, but it won't go there. Sure. Okay, fine. I'll deal with that later. Oh, great. I'm glad that's there now. I can't make this any smaller. I mean, I really feel like those numbers should be changing a little bit. Because I definitely allocate all over the place. Yeah, why bytes go up, count not? I guess. Then why is so this could be right. Like I could just be. Can I add something to the scene? Can I force like a reallocation of something? What if I add one of these? I wasn't paying attention. Did that change it? What if I duplicate it? Oh yeah, okay, fine. Okay, maybe I'm just not. Maybe I've just have everything allocated. I've got the most efficient. Why is total? Because total allocated bytes doesn't account for the what you've deallocated. Because by the end of the, I think what's happening is every time count goes up, it's. I think within the frame itself, I'm allocating and deallocating stuff, right? So the net effect is I have 0 more allocations. Interesting. How interesting. Yes, this should probably be live allocation count, and this is the total allocated bytes. Yes. Yeah, that should be live count. Do we want the total count as well? Do we want that? Okay. I'm kind of annoyed I can't dock it to this, but we'll sort that out later. Okay, so we want metrics. So we want total allocation count, total allocated bytes, and then we want live allocation count. Live allocation count, total allocation count, total allocated bytes, live allocated bytes. Live, so I allocate the frame buffers, right? The command buffers are not. So this is interesting. The command buffers should be effectively static, or at least not probably rebuilt per frame. But I do build a lot of that, I think, per frame. And some of the other stuff that I suppose if you go to renderer. Ranges. There you go. There's one. I know maybe that's in the initialization. Oh, do I not? I thought I had some doing it in here. Anyway, I'm sure I do. Okay. Anyway, so let's go back to new because this is now. So hang on, we want in new, we want total allocation count and live allocation count, and then total allocated bytes and live allocated bytes. And then in the delete, we just update the live ones. And the debug renderer, live allocation count, total allocated bytes, live allocated bytes, live allocated bytes. Right. Okay. So we're doing lots of allocations. But it's pretty stable at the end of the from frame to frame. So at least we've got no leaks, I guess. I guess a lot of this space will be the fact that we have copies of all the GPU buffers and CPU memory. Well, yeah, because that's just the total that I've done over the lifetime of the game. It will never go down because we never decrement it, right? I think if you want to see what it's doing, we would have to introduce stack tracing into new, which is not, and then keep track of those, which is not too much effort. And with something we're going to have to do it. We're going to have to do a lot of that machinery anyway when it comes to profiling threads. So I'll probably just reuse that, and then we can maybe have just like, it might be interesting to see a snapshot of like what each thread is doing, and then also just a snapshot of where all the allocations are happening. So we can definitely do something like that. Again, I think this metrics window should hopefully build out quite nicely as we get around to it. I'm just thinking what's useful to do now. Do we want to do per frame stuff? Because we could basically just take a snapshot. How's that going to work? We could store the allocations for a given frame. Can you do that with printf? I don't know if you can you? I don't really use printf. Oh, apparently you can do that. No, you cannot. ISO does not support the printf. It's a C thing. Probably there's like some weird locale reason for it. Anyway, sort that out another day. We could just divide it. Anyway, let's just super quickly see if we can do third atomic third size T frame allocated bytes. Okay, and then we're going to do should definitely be reflection. Dot frame allocated bytes equals G metrics dot frame allocated bytes dot load stirred memory order relaxed. Okay. Let's do that, and then what we can then do is in main we can do hash include memory metrics, and then right at the end of the frame, after we to drain the pools, right? So we know at this point there are no more allocations happening for this frame because all the work queues have been drained. We should be able to do G UFS G metrics dot hang on oh yes, well done. Sorry, it's here. Well done. G metrics. So hang on, I want to take I need to track what it was at the beginning of the frame, don't I? And then add that on. So let's do. So at the first thing in the frame, we'll do const auto current allocated bytes equals G metrics dot total allocated bytes dot load stood memory order relaxed, and then here we'll do const auto actually begin frame allocated bytes end frame allocated bytes, and then we can do G metrics dot frame allocated bytes dot what's it if you want to just set the value without incrementing it? Can I do that? Have I got to copy and swap it? Just dot load, isn't it? No, that's store. Thank you. Dot store end frame allocated bytes minus begin frame allocated bytes stood memory order relaxed. Okay. Okay, so that allocate. Yeah. Okay, so that should now that will obviously flicker loads, but what we can do is we can use that to build out a graph, right? So I guess we might be always one frame behind, but we should have access to that data. Let's do debugger renderer. I'm just going to slap this in now. It won't make much sense, but let's. Let's just check we've got this wired up. Because then we can plot per frame how much allocation we're doing. Ah, interesting. Okay. Let's reasonably stable. So I'm doing 74k of allocations per frame. What we could do, if we need to, is we could overlook. So I did this for the Dragon Age video where I put in some metrics. Is we could create custom allocators for ImGUI and then have those not add to the metrics. So we just totally discount all this from our actual code, which might be useful to do. It's really not a lot of effort. We could just create a private heap for those, and then just use free heap alloc on those, and then it's kind of up to it can just do whatever it wants then, but it won't go through our. Oh no! Ooh, does it call new anyway? It's a C++ library. It's very C focused. I wonder if it just uses malloc under the hood anyway. I'd have to look at that. I'm not sure if the ImGUI code is going through our operator news. Yes, I'm aware of that, but by default, does it call operator new? Let's it is operator new. Okay, fine. Well, I might add that later. For now, I want to have a quick look at what was the name? Source. I'm just looking at the ImGUI code I wrote for the Dragon Age stuff. Okay, fine. Let's see if we can super quickly put this in. So I'm going to static frame allocations equals std vector std size t. How many plot points do we want? 100? 1,000. I used 1,000. So let's do 1,000 U, right? It's malloc and free by default. I just checked. Okay, so I don't care then. It can do its own thing and live in its own little world. Okay, so then what we're going to do is we're going to do frame allocations dot erase std ranges begin frame allocations. This is going to cause a lot of churn anyway. That's fine. And then frame allocations dot push back m dot frame allocated bytes. All right, so this it's not great, but it just pops the one off the front and then puts the next one on the end. So we'll have this rolling window of frame allocated bytes. Okay, and then we should be able to do ImGUI plot lines. I'm going to call this frame allocator, frame allocations. Might need to divide this, scale it down or make it logarithmic or something. But anyway, for now it'll be fine. We're going to do frame allocations dot data. Oh, it's got to be floats. Allocations dot. What did I do? Oh, I did make them float. Okay, fine. Dot size. Fix that in a second. 0. I'm just copying off the code I've written before for this, by the way. So I'm pretty sure I don't want any of these. 0.0f std numeric limits float. Like, let it figure out the scale. Imbec. Apparently I did this. I think it just sets the size. Imbec to 0. 80.0 f 80.0 f. The double colon is just the global namespace operator. Just instantly allows me to have access to everything that's global namespace, but I use it as a visual indicator to show that this is code that I didn't write. It won't like that because this now needs to be, hang on, C. Ooh, hang on, CI close, yeah. And then this is going to push back a static cast float divided by 1024.0 f. Just make those values just a little bit smaller. Probably don't need to put that in brackets. That's probably fine. Okay. All right. Should we see if that blends? It's kind of ironic that the code to track and display the memory allocations will itself incur memory allocations. I guess it's mainly memory move. It's just going to move the stuff across, so it's not too bad. Okay. So at least it is roughly stable. I guess if I just add something to the scene, pick your favorite gate. Just like duplicate that. You can see it go up. Interesting that it doesn't go back down to normal, so there must be the what I allocate per frame is therefore correlated to what I have in the scene, which I guess makes sense. Probably right. I mean, it won't be the ranges are lazy, right? But I will probably reify that with a stud ranges to stud vector or something at some point. So it's probably that point, but I don't think ranges itself is inherently allocating. Okay, interesting. I think that's useful. Yeah, we do. I think we need to go back and probably profile this a bit further to actually see where the allocations are happening. Oh, it's dark as shit, I can't see anything. Where's the ambient light? Doesn't help that the fog is quite aggressive. I need to fix this docking thing as well. That's better. It's nice that we can have kind of like a reasonably well lit scene as well, which kind of looks all right, and then we can turn the lights off quite easily because this looks. You still got the glow here. You still got like the glowing lights. Like I think I've got the lighting values reasonably tuned in now. I think. Okay. Still a little bit of blur there from the bloom, which I think the fog does a good job of hiding. Okay, right. Add metric struct integrate integrate metrics into new add frame metrics commit render metrics. Okay. Have I? Oh yeah. Oh man, I really gave it a good go, didn't I? Have I got them all? Oh, Mertix. Hang on. Oh, what keeps happening? What? Getting eggy with this. Why am I struggling to reword this one? R. Okay. That was painful. Okay, so we're on stream 34. Still in the GitHole. Right. I was good. I think we did a lot there. I had fun playing around with the alignment stuff. It was a bit of a pain, and it took probably long, as always, it took longer than I expected, but didn't we all learn something today? I think it was worth doing. I'm kind of pleased that's in there now, because hopefully I can kind of forget about it for a bit. So next stream, I think we've got the basic metrics in there now. I don't think it's that useful to us at the moment, so I'm probably going to go on to do the thread profiling, because I think that'll give us a bunch of other machinery to dive into the allocation stuff deeper. I think again, there's not necessarily anything we're going to change now because of these metrics, but I think it's useful for it to be there as we kind of go forward. The other thing I want to do is have like a heuristic attempt at logging the GPU allocations, and then I want to do the OpenGL GL begin counter, end counter, whatever it is. So I want to set GL timers for all the render passes, and then log those over time, or at least as a snapshot, so we can see how long each part of our pipeline takes. Yeah, exactly. But so for the thread profile, so for the runtime profiling, the sampling profiler, we will have to add a bunch of machinery for us to be able to say, hey, point at a thread and say, hey, what are you currently executing? And then that we can integrate that potentially into the allocator. So we could just keep a track of where every allocation comes from. It's quite heavy, but might be useful. That's all I've got. I think today's Wednesday. God, today's Wednesday. Sunday. We'll do some more, and we'll write more code, and we'll have more bugs, and the grand time will be had by all. Before everyone disappears, new video soon, ? I think I'm about 10% of the way editing it, so I'm hoping by next week. It just depends how busy I am. That's all I've got. Thank you very much for joining me, and I'll see you all anon.